All right, let's try this again. My document camera seems to keep cutting off. Welcome again, my students and students of the world out there who are viewing this video. In this one, I'm going to do this for my students. Our students and I are doing from our textbook. This is section 3.4, multiplying mixed numbers with area model. So I'm going to do this using the first example here, which is 2.5 multiplied by 1 3/4. I'm also going to show you how to transform this into an improper fraction, mixed numbers into improper fraction, and back, improper fractions back to mixed numbers. First, what I think I'm going to do is I'm going to do the area model for this. So what does the area model suggest? Well, it suggests that we have a length and we have a width that we're going to multiply. And in the end, that'll be the area of this rectangle. So in this first example, the length will be 2.5. Well, how are we going to show 2.5? How about we just divide this into 2 here and 1/2 over here. So there is my 2.5. Now on this side, we want to make this width 1 3/4. Well, let's just show that by doing this. I know it's not quite proportional, but good enough. 1 over here and 3/4 over here. And so now we're just really going to find the area of each of these little parts, and then in the end we're going to add them up. Okay? And this is really the challenging part about this is actually the adding portion of this area model. Okay? But I believe in you, and you guys can do this. I'm also going to review adding fractions along the way. So, what is the area of this little rectangle over here? Well, that's just 2 times 1, which is equal to 2. What is the area of this little rectangle over here? Well, that's just 1 times 1/2, which is equal to 1/2. What about this area right here? 2 times 3/4. Well, 2 times 3/4, we can do this. And if you recall, multiplying whole numbers with a fraction, you just rewrite this whole number as a fraction over 1, and then you multiply the numerators and denominators. So this becomes 6 over 4. Okay, and yet we have to reduce this because this then becomes a long division, which I'm going to do over here. Watch this over here. This is actually 6 divided by 4, or 6 divided by 4. How many 4s are in 6? I think there is 1. 1 times 4 here is 4. And reducing this, or subtracting this, will give you the remainder 2 over 4. But, please note that there is a common factor of 2 in both of these. Are both even numbers. So what I'm going to do is I'm going to divide top and bottom here by 2. And our answer for this is actually 1.5. Okay. There is also a video where I actually show how reducing fractions shows us long division, and I also have videos on how to multiply whole numbers with fractions, etc. And I also have a video showing how to add fractions. So I'm going to include those in the description below, and you can view those later on if you need to. Last one is 1/2 times 3/4. And I believe that'll then be equal to 3/8. So those are the numbers we have to add to get the entire area of this rectangle. Whew. Well, that is the most challenging part about this area model, is adding these fractions up later on. Okay, so let's add this up then. 2 plus 1.5 plus 1/2 plus 3/8. This looks like a mess, but there is a trick you can do. You can just go ahead and add up the whole numbers if you like. And that's what I'd prefer to do. And then you can add up the fractions separately, like so. And so now we just need a common denominator between 2, 4, and 8, which I think will be 8. Good for you. I knew you'd figure it out before me. So 2 plus 1 here is, we can add the whole numbers right away if we want. That's 3. But fractions, we need a denominator. Each of these needs a denominator of 8 because that is the lowest common denominator. I don't have to change the 3 eighths because our lowest common denominator is 8. It's just these two that we're going to have to change. Okay? So how do you make a 1/2 or this 1/2 into denominator 8? Well, what do you have to do to 2 to make it an 8? Probably multiplied by 4. So this then becomes 4 over 8, and this is also 1/2, so it's going to be exactly the same thing. And so there's the fractions we have to add up. Okay? So let's see what we get in the end here. We'll write this 3, and 4 plus 4 is 8, plus 3 is 11. And yet we still have to reduce this before we can add this to this 3. Okay, so this 11 over 8 becomes 11 divided by 8, which transforms into 11 divided by 8. So how many 8s are in 11? 1. 1 times 8 is 8, and our remainder is 3. So our answer here is 1 3/8. And now here we go again. We can just go ahead and add these whole numbers and the fractions, and we're going to get 4 3/8 as our final answer. Whew, that is a doozy, but that's how you model multiplying mixed numbers. Now, what we're going to do is just see what it looks like if we just do the math part. Okay, so using the same example, put this aside for now, new sheet, same example, this time it's just going to be multiplying, strictly multiplying mixed numbers. So 2.5 times 3/4 again. So this is a skill that I want you to take your time paying attention to, and rewind the video if you need to, just so you can recall it over and over. To transform, before we can multiply it, we need to transform both of these into improper fractions. Okay, and to do that, really, I put an arrow in a clockwise direction here. Hello, focus, focus. We multiply these two numbers here first, 2 times 2. And then we add the top number. So 2 times 2 here is 4, plus 1 is 5 over 2. Same thing. 4 times 1 over here, multiply, and then add the top number. 4 times 1 is 4, plus 3 is 7 over 4. Okay? It doesn't look like we have common factors in either diagonals here, so we're just going to have a doozy multiplying these out and then reducing them in the end, which is a challenge, but we can do this. So 5 times 7 in the top, numerators, 2 times 4 in the bottom, denominators, and we get 35 over 8. It seems like we're doing pretty good so far because our denominator is 8 in our last answer, isn't it? So, unfortunately, this is a top-heavy number or improper fraction, so this is going to have to transform into a division. 35 divided by 8, also known and long division world, 35 over 8. Yes, it's a skill that I don't think should become obsolete or be forgotten about. I know we all have calculators, but again, transforming this into a mixed number, the calculator is not going to be able to help you because it's going to give you a decimal. Unless, of course, you really have one of those special calculators that does that for you. But let's not lose this skill, okay, people? This is a good skill. I'd like all my students to be able to graduate from university knowing how to do this skill. So, how many 8s are in 35? I think approximately 4, because 4 times 8 is 32. Okay? And again, students, now you know why I advise you and emphasize for you to get to know your multiplication table. So now, 35 minus 32 is 3, and there's our remainder, 4, and 3 over 8. Well, isn't that the answer that we got in our previous example when we were doing the area model? Yes, it is. See? Okay? So those are some of the skills you're going to need to learn, okay? You need to be able to transform mixed numbers into proper fractions and improper fractions back to mixed numbers. So let's just do a couple more examples of that, and maybe I'll do one more example of multiplying mixed numbers. Let's see. 2 and 3/5. How do you transform this into an improper fraction? Again, you multiply these two numbers, and gives you 10, and add this top number, will give you 13. And maybe I'll write it out like this. 5 times 2 first, in brackets, and then you add the 3 in the end. All this while being over 5. So if this other way helps you, then I hope it does, okay? Now, let's transform an improper fraction into a mixed number, which, again, you will have no choice. Oops, let's not do this one. How about this one? 19 over 6. Okay? How do you transform this without using a calculator into a mixed number? Well, it really does have to be done by long division, and I apologize to those students that do not like to do long divisions, but it's a must in this case. So how many 6 are there in 19? I believe there are 3, because 3 times 6 is 18 without going over 19, and 19 minus 18 here is 1. So our answer is 3 and 1/6. Okay? Long division, people. Can't run away from it. Okay? Forever. It eventually does catch up to you. Alright. One more example of multiplying mixed number, and I think we are done for this session. Here we go. Let's try another one here. How about this one? 2 5/8 multiplied by 1 and 5/7. Okay, we just finished showing you how to transform a mixed number into an improper fraction, so that's what we're going to have to do first. Okay, multiply these two numbers first. Keep it in mind, okay, 8 times 2 is 16. You should keep that in your head. 16 plus 5 will be 21 over 8. Oops, this is not adding, this is multiplying. 1 times 7 is 7 plus 5. 7 plus 5 is 12 over 7. Look at this example. Oh, you geniuses out there, you good-looking students out there, can you see there are common factors in these diagonal numerators and denominators? Do you see it? Yes, good for you. You guys are so good out there. 7 is a common factor between 7 and 21, so what I'm going to do here is divide both of those by 7. Oops, just gave you the answer. The 21 divided by 7 is 3. 7 divided by 7 is 1. Do you see a common factor between 8 and 12? Well, yes, it is 4. 8 divided by 4 is 2. 12 divided by 4 is 3. And now, we've made our life just a little easier, because now our multiplication is not 21 times 12. That's going to be a huge number. Over 8 times 7, which is 56. That's a huge number. I don't want to have to do that, so thank God we reduced this first into 3 over 2 times 3 over 1, which gives us 9 over 2. And now we can just transform this back into a mixed number. 2 into 9, that is 4. 4 times 2 is 8. And subtracting this, we get 1 over 2. And here is our answer, 4.5. Okay, so hope this does help. Okay, and I wish you luck in this assignment. Again, the key is transforming mixed numbers into improper fractions and improper fractions back to mixed numbers. If you can see that you can reduce fractions first, do that first. If you can perform the area model, it's great. Okay, and here's our area model. Okay, so thank you for watching, and I wish you luck. Bye bye for now.